Here are some example problems involving torque. Before starting, it is strongly recommended that you review the video that introduces the definition of torque, as well as its angular and radial considerations. In our first example, we have two entities pushing against each other at different distances and different angles from the hinge. For all torque problems, as a first step, reading the problem, take note of all radial distances, hints about the magnitude of forces, and directions. Take note of what is being asked for. As with all force problems, you must draw a free body diagram with both Cartesian and angular coordinate systems. List all three variables for each of the forces. Take note if the direction of a force is in the negative angular direction. Apply Newton's second law in the angular system. Net torque equals moment of inertia times angular acceleration. Note that in this case, the latter two quantities are not specified, but based on reading the problem, we know that we must have a positive angular acceleration. Solve algebraically and plug in with units. Take care at this step that the negative signs are plugged in such a way that the answer is physically sound. Reread the problem and make sure you have answered the question. In our case, the answer implies that the scenario is not possible, and hence the hero needs to keep running or find a way to weaken the werewolf. In our second example, we are pitting the motor of a grinding wheel versus a rough surface. For torque problems, you will need to take note of radial distances, magnitudes of forces, and directions. For torque problems involving angular kinematics, you will need to take note of all of those quantities as well. As always, note carefully what is being asked for. If you see any quantity in non-standard units, make sure to immediately convert them. Draw the free body diagram for all of the forces and set up the coordinate systems. In this problem, the Cartesian coordinate system will not be used, but it is good practice to remember to set it up as well. List the relevant variables for each of the forces and make sure to take note of the positive or negative sign of the angle relative to the coordinate system you have set up. Set up the angular version of Newton's second law solve for the unknown algebraically and then plug in bit units, remembering to include the negative sign for any angles. We are not done yet because the unknown we are asked to find is time. Flip to the relevant kinematic equation, solve for the unknown, and then plug in with units. As always, check that you have answered the question sensibly by rereading the problem and checking against the picture.